We spend a lot of time projecting our wildest sci-fi fantasies onto the safety of a movie screen. We invent dark lords, alien empires, and impossible planets from the comfort of our own world. But pull back from our fiction and look at the physical reality of our universe. There are an estimated 2 trillion galaxies out there. Inside our own Milky Way alone, there are hundreds of billions of stars, each anchoring their own systems. With these massive numbers, extreme planetary conditions shift from imagination into statistical inevitability. These are physical realities existing right now in the deep black. So today, we are leaving the safety of Earth. We are charting a course into the deep black to visit 5 of the most terrifying, bizarre places we have actively discovered. What we find out there proves that the actual laws of physics create environments far more awe-inspiring and deadly than any fictional script. Our first stop sits 245 light-years away. It's a gas giant roughly the size of Saturn named Kepler 16b, often called the real-life Tatooine. This animation shows exactly why it earned that nickname. Kepler 16b was the first planet we found in a circumbinary orbit. That is the scientific way of saying it orbits around a core of 2 distinct, separate stars. If you could stand on its surface, you would literally watch a double sunset every evening. But don't pack your bags yet. Notice where the planet actually sits in the system. It revolves far outside the habitable zone, the exact distance required for a planet to maintain liquid water. Without enough heat from either of its suns, the surface is a freezing, inhospitable trap. Finding a world that is actually hospitable is incredibly difficult, but astronomers have found promising candidates, like Kepler 186f. It sits perfectly within its system's habitable zone. The catch is that its central star is much cooler and redder than our Sun. Because the planet is bombarded primarily by red wavelengths of light, any plant life developing photosynthesis there would likely bypass green entirely. You'd be walking through forests of blood-red trees and eating bright red lettuce. And if you want another visual spectacle, look at J1407b, often called Super Saturn. It has rings 640 times larger than Saturn's. If we swapped it into our own solar system, those massive rings would easily dominate our night sky, appearing significantly larger and brighter than a full moon. But we have to be careful. Out here, a beautiful sky usually masks a bizarre and hostile set of physical rules. Take HD 189733b, a world astronomers nicknamed the Planet of Terror. From a distance, it looks like a gorgeous, deep azure blue marble. It mimics the welcoming, serene skies of Earth. But the second you enter its atmosphere, your ship would be caught in winds blowing at 5,400 miles per hour. That is 7 times the speed of sound. Any probe we send would be violently ripped off course in a fraction of a second. The source of that inviting blue color isn't an ocean of water. The planet's atmosphere is packed with silicate particles. Under the intense heat of its nearby star, those silicates condense and fall as a blinding rain of 500-degree molten glass. Now combine that precipitation with those hypersonic winds. The glass doesn't fall down. It rips horizontally across the surface at thousands of miles per hour, shredding absolutely everything in its path. In the cosmos, a familiar blue sky can serve as perfect camouflage for absolute, immediate destruction. To find our most terrifying destination, we have to leave solar systems entirely. We are heading into the freezing, empty voids between the stars. This visualization demonstrates how rogue planets are born. When a new solar system is forming, gravitational forces are incredibly chaotic. Sometimes a planet smashes into another planet, or a massive gas giant acts like a gravitational slingshot, kicking a younger planet out of its home system entirely. Now they are untethered. They don't orbit anything. They simply drift through the pitch-black depths of space. Without a sun to warm them, they begin to freeze. But as their internal molten cores cool down, some of these isolated worlds experience weather patterns where it literally rains bands of liquid iron in the dark. Millions of these dead worlds are wandering through the darkness right now. The mathematical odds are low, but if one happened to drift through our own solar system, its massive gravitational pull could easily drag Earth out of orbit and toss us into the void. These roaming invisible worlds are a silent gravitational threat, wandering the void with the power to destabilize entire solar systems by pure chance. Let's turn the ship around. We can trace our path back out of the deep void, past the supersonic storms of glass, and away from the frozen twin suns, until we reach the quiet edge of our own solar system. These environments are physical realities, actively grinding away in the deep black while we go about our lives on Earth. Right at this very second, iron reigns in the pitch black. Glass shreds a blue atmosphere. We are a very young species, taking incredibly tentative steps off a tiny rock. For all our ambition and dreaming, our physical foothold in this immense, chaotic universe is basically non-existent. Understanding the brutal, extreme physical laws grinding away out there makes our quiet, safe existence on Earth feel incredibly rare and precious.